So on Tuesday, some of you were with me when I tried to lecture from the school, and I do appreciate your patience, but it was a disaster. The internet kept going in and out. I kept getting kicked out of the room. Students had a hard time hearing me. So I found out that they've actually shut off all the Wi-Fi at the school because technically we're not there. So I didn't want that to happen today. So this is going to be a review of the Isomer lesson that you're supposed to watch on Edpuzzle, or if you were joining me for live lessons, I'm going to go through it now, and then I'm going to lead in right into the lab that you're supposed to be working on today. I do want to make it very clear that I expect you to continue working on the lab after the lesson, and if you need additional help, I will be in office hours tomorrow. That is May 22nd, and Tuesday, which was a holiday, is no longer a holiday. They took that away. Just kidding. No, I'm really serious. They took away our holiday on Tuesday. So we actually have class on Tuesday. So I will help you on Tuesday at the end of class if you show up for a live lesson and you still need help. All right, so let's get started. Iso, the prefix, means same. You may have talked about in math isosceles triangles, so triangles with the same angle. So isomers are compounds that have the same molecular formula, meaning the same number of each type of element. So they might have 4 carbons and 10 hydrogens, but they have a different structural formula. So the elements are arranged differently, and because they're arranged differently, they have different names, and that also means different physical and chemical properties. You have to have at least 4 carbons, so it's got to be at least C4 or higher in order to create an isomer, because anything less than that, you would not be able to change or move the carbons in an arrangement that would be different from the original. So therefore, anything with meth, eth, or prop do not have any isomers because you can't move them anywhere. So there are 3 different ways that you can make an isomer. You can make a branch, and for those of you that have already watched that lesson, you know what I'm talking about. You can move a branch, so you've got an existing branch and you're just going to move it somewhere else. Or you can move a multiple bond, which means a double or a triple bond. So we're going to work with pentane in order to demonstrate what an isomer is. So one isomer of pentane is the actual normal structure, 5 carbons and 12 hydrogens. Now, what I'm going to say is the easiest way to make an isomer is take one off the end. So take typically this one off the end and move it somewhere else. But what I want to show you is if I take that one off the end, you don't want to move it here. You do not want to move it there. That is a no, because all then, and I didn't draw in my H's here, but all you did was actually bend the chain. So that is still pentane. So don't do that. When you take it off the end, stick it somewhere in the middle. Like you can see here, they moved it not to the end carbon, but they moved it to the second carbon. And you might say, well, second carbon, that's the third carbon. But remember, we number the chain left to right, right to left, so that the branch gets the lowest number. So in this case, if we number from right to left, it's 1, 2, 3, 4. This would be on the second carbon. So now my parent chain is only 4 carbons long, and that prefix is bute. It's all single bonds, so it ends in ane. And I have 1 C coming off the second carbon, which is a methyl group. I have to give its location, so it's 2-methylbutene. All right. I can now remove a second carbon. So let's say I remove this end carbon from here and I move it over here. That will create this molecule right here at the end. So now it doesn't matter which way I number, left to right or right to left, because they are both on the middle carbon. So now my parent chain is only 3 long, which is prop, all single bonds, ends in ane. I have 2 methyl groups, one here and one here. They're both the same, so that gives me dimethyl, and then I have to name the location. I must name both locations, so it's 2,2-dimethyl propane. Notice you can only make branches on non-terminal carbons. And what we mean by terminal carbons is what I showed you in the first picture. You cannot take a carbon and move it over here to the end because it only bends the chain. Do not do that. It will not count. So now we're going to practice with pentene isomers. Pentene has a double bond. So the first thing that I'm going to do is draw my 5 carbons. It's an ene, I need a double bond, so I'll put it on the first carbon because normally if there's no number it implies 1. I'm going to put in all my H's, make sure each carbon has 4 bonds. This has already got 3, so I only add 1. This has got 2, I add 2 for 4. Remember, it doesn't matter what side you put the H's on because we're drawing a 3-dimensional model in a 2-dimensional space. All right, so what's the easiest thing to do? The easiest thing to do is to move the position of the bond. So this is just pentene. The next thing I'm going to do is move the bond because that creates a new compound. So I'm going to put it there. I'm going to put in my H's. This is now an isomer. This is now 2-pentene. All right. My 2's like looking kind of funky. There we go. Now we're going to do something a little different. I cannot move the bond to the next position because I'm going to just show you that up here. If I move that double bond one more down, so it's here, then if I number from right to left, it's really on the second carbon. So it's the same as the first one that I drew. So now what I have to do is try to do something creative. So I'm going to put my double bond back where it was, and I'm going to take off a C and I'm going to move it somewhere else. So now my parent chain is only 4 long. So the prefix for 4 is bute, and it's got a double bond, so it's butene. I could put 1-butene, but I don't have to. And I have a methyl group on the 3rd carbon. So this is 3-methyl, and it can be just 3-methyl-butene or 3-methyl-1-butene. The other thing that I can do is I can do the same thing to this one. So let's work with the one that we did up here. My double bond was on the 1, 2. So it was here. And I'm going to take off an end carbon. I drew all of them in. Let me get an eraser. I'm going to take this one off. There we go. And let's move it here. Okay, so now let's name my parent chain. So my bond is on the 2nd, so this is going to be 2-butene. And I have a methyl group on the 2nd. So this is 2-methyl, 2-butene. Now I can't move, I'm just going to draw this in yellow like as in a highlighter. I cannot move this carbon over here because then I would be numbering from right to left, and it would still be 2-methyl-2-butene. So those are examples of isomers, or how to construct isomers and name them. So now, going to the Isomer Lab. In Teams, I've posted the Isomer Lab. I'm not going to go through all of this, but on the lab, it's really cool because you have all of the prefix right here. So if your main chain carbon, so your parent chain, so I'm just going to label this parent. So if your parent chain has so many carbons, here's the prefixes for the parent chain. So 5 is pent, 7 is hept. Now, here are your side chains. So these are for your branches. Okay, these are for your branches. So if you only have one, it's like 2-methyl. Okay, if I have 2 methyl groups, like I just demonstrated, then we would use one of the side chain prefixes, like di. If I have 3 methyls, then it would be tri. But remember, if you use di or tri in front of a methyl group, which is a branch, you need to tell me the location of those. So is it 2,2 dimethyl? Is it 1,2,3 trimethyl? So remember to do that. Now, on this example here, this is kind of one that we just did, 1, 2, 3, 4, 5. This comes from pentane. They put a branch right over here. So our parent chain is now butane. And there's like a little typo here. There should be like 2-methylbutane. They need another 2 in there. So it's 2-methylbutane. So what you are going to do is you are going to draw 9 drawings when you are completely done for this lab. So you can do these on a separate piece of paper and upload them, and I would suggest doing them in pencil, because my experience with students doing this for the very first time is they think that they've really created an isomer, and they really haven't. They've either bent the chain, or if you count right to left or left to right, it's the exact same structure. So you are going to draw heptane. So hept is 7 carbons, right? So I will get you started so that make sure that you have the correct parent structure. So we're going to draw heptane. Hept means 7, ane means all single bonds. So I'm not giving you anything complicated in this. You're not having anything that has a multiple bond. So that tells you if you don't start with a compound that has a multiple bond in it, you cannot just arbitrarily add a multiple bond. So we have 1, 2, 3, 4, 5, 6, 7. I'm going to put in lines for my H's. If you want to draw in all your H's, have at it, okay? Just a little too much work for me. So you make sure that you name it. I've named it heptane. And now you need 8 more accurately named true isomers and their drawings. Okay. Have a good day.